Hello, this is Gary Klass from Wells Fargo Bank in San Francisco, California. Thanks for inviting me to speak today. I'm going to be talking about advanced analytics and the importance of early adoption of an analytics platform at Wells Fargo Bank. Giving you some background and some examples of things we've been working on. First, we want to define what is advanced analytics. So one definition that I think works very well comes from Gartner. And they say that advanced analytics is the semi-autonomous examination of data or content using sophisticated techniques and tools to discover deeper insights, make predictions or recommendations. And the key point they make is beyond those traditional business intelligence, sort of traditional reporting, focused on more complex techniques. The semi-autonomous part is also important too, basically to try to automate as much as possible so everything isn't customized, bespoke analysis. So some of the techniques involved are included in advanced analytics are machine learning, data mining, predictive analytics, location analytics, which is one of my personal favorites, big fan of spatial data, and advanced visualizations. And I'll be sharing some examples of all of these here in this presentation. And then regarding advanced analytics, my friend Tom Davenport has three phases that he's identified. The first is descriptive, what has happened. The second is predictive, what do you think will happen? And the last is prescriptive, what would you like to have happen? And once you get to the third state, prescriptive is kind of where a lot of really the value pays off in advanced analytics, because that can directly inform your company's strategy and tactics. So the advanced analytic engine we're talking about is Teradata Vantage, the latest offering from Teradata. I've been a Wells Fargo has been a Teradata client since 1999 when I brought them in. We also adopted the Teradata Aster platform in 2014 with much success. And now we're engaged in Teradata Vantage. So the key point that I'm going to focus on today is kind of in the center, which are the analytic engines available. SQL engine for queries, the machine learning engine to support most families of advanced analytics, and then finally the graph engine, which I think is kind of the hidden jewel of Teradata Vantage. A graph is a way to organize and dimension data for relationships. It's very interesting, and I'll show you an example of that. And then the analytic languages that can be used. We'll give you some examples of projects we've done with SQL, Python, and R. We generally use R as our modeling language going forward. At Wells Fargo, we're really focused on the idea of customer journey. How do our customers solve problems and navigate their financial life with the bank? And then we introduced this idea of a customer sojourn, which is the customer's journey as reflected in the data that the bank can capture about those customers' interactions with the bank. Context here is retail banking. Wells Fargo is one of the largest retail banks in the United States. And we've kind of followed the progression as banking has evolved with technology to meet customer needs. So kind of all started with branches. Tellers to handle the cash, bankers to answer questions and open accounts. ATMs came to California, I was told, about 1977. Phone channel, about 30 years ago, this was all the rage. 24-hour phone service, you could talk to a person 24 hours a day, that's the banker. The IVRU is the speak the phrase or hit the buttons on your phone to get information. And a lot of focus now on what we call banker chat, which is the ability of our customers to chat with phone bankers. And then online, which is by far the most voluminous channel. It's been about a 20-25 year exercise. Wells Fargo was very early to develop and deploy online banking. Wells Fargo actually made the first transaction that ever happened over the internet for a bank. So inbound email, the original desktop, a lot of the focus today is mobile as customers increasingly leverage their smartphone. We also have a capability where we have bankers listen to social media and reach out to customers to try to help them solve their problems. So a lot of different channels, a lot of different types of information that we have to collect and process and understand. So that gets us to this visualization of the customer sojourn, and we have a data environment we call CSI 360, Customer Service Interactions 360-degree view of the customer. And this illustration and all the circles are really the silos of the data. Each channel has its kind of own quirks. Each channel has evolved over time to be somewhat autonomous. A long run challenge to take this information and sort of unwind it to make it useful for us. And we're really looking for three things in that channel data. Who is the customer, which is more difficult than you might think to identify sometimes. The session, the activity that happened in the channel from the beginning to the end. Think about log on, log off in digital banking. And then kind of a new term, sojourn. It's from the Latin word for trip. And that's to take the customer's activity as they navigate the various channels to solve a problem. So that sequence can either be asynchronous, customer may be on the phone and later that day go to a bank branch, or it could be in parallel where the customer is engaged in digital banking while they're on the phone with the phone agent, which is happening with increasing frequency. So having CSI 360 and the Vantage technology, we can actually really understand and identify these customer sojourns. We're going to showcase some analytics we've done with Teradata, using Teradata technology. The customer sojourn I talked about, we're going to visualize it with path analysis. An advanced analytical technique to understand how customers progress through segments called a hidden Markov model. As promised, an illustration of graph analysis, in this case for payments. Text disambiguation, really about firm name, and then kind of the one we're kind of most proud of and focus on increasingly is identifying why customers are contacting the bank. In this case, it's going to be the model that we developed to infer and assign a call reason to inbound phone contact. This is an illustration of what's known as a Sankey diagram, sort of ribbons of data, as customers flow through states in CSI 360 through time. The thickness of the line is the volume, and you can see the various colors identify the various paths. So our terminal node over there on the right is customer transfer. So this is all the different ways that customers navigated to make a transfer in digital banking. Multiple steps. Sometimes customers get kind of stuck in a loop. This information as visualized is a great way for us to understand how effective our service channels are in helping customers resolve their customer task. This is what's known as a sigma diagram, where you take all the different transitions, in this case across segments. So we have a segmentation that looks at customers' in-person banking on one dimension, and then on another dimension is their engagement in digital banking. And all customers are assigned to one of these 25 elements in the segmentation. And here we're looking at all the different transitions that happen from one month to another. And you'll see that the sort of larger letters are the largest segments up at the top. Branch inactive, not 3-month active, means that the customers really aren't doing much of anything. It's a fairly large population of relatively dormant customers. So anytime they kind of wake up and do something in a channel, it's pretty important. And then down the bottom are customers that go to the branch every month, but don't use digital banking. And obviously that's something that we'd like to see happen less. So anytime a customer sort of begins to start to engage in digital banking, it's a major activity that we want to observe. But really what we're trying to do is measure, understand, and model these customer transitions across segments in all our local markets. I talked about graph analysis. Here's an illustration for payments. So we really focus on person-to-person payments, which unlike in the Nordics, it's not something that's easily done. It's a little bit late to the game here in the United States. There's a lot of non-bank providers like Venmo, but banks have developed their own capability called Zelle, which we're really focused on. And what we're trying to do is understand what's the untapped audience for Zelle. How can we get more of our customers to feel comfortable using it? And part of what we've identified is looking at payments data to see the payer and payee relationship and sort of see how people pay one another through traditional payment instruments. And then we have found that if one of that circle of people starts to use a digital payments to payments provider, hopefully Zelle, that other people in their network will begin to use it. We can actually measure that and model it through what's known as a network graph, or in this case, a payment network graph. There's a lot of applications of text disambiguation. Increasingly, we're dealing with unstructured data, be it sort of banker notes or emails or transcripts of calls. So we leverage the Teradata platform to process that unstructured text data. Here's one example that I thought was pretty interesting that's around resolving company hierarchy. In the United States, insurance companies are chartered by US state, and there's 50 US states and other territories. So a entity diagram, pardon me, for an insurance company can be pretty complicated because they have multiple subsidiaries, different lines of business in different states. And here's an exercise where we had to disambiguate and find who's the parent company of all these subsidiaries, and you can use this process to sort of resolve ambiguity. We do a lot of work with, as I said, analyzing payments, and it becomes very important to distill who is the payee in a payment, which we call global payee, and try to match them to a master list of businesses, which is part of what this project was about in this case. How do we resolve to the master insurance company, in this case, Nationwide? One of the things we've been really focused on providing and trying to deploy is inferring what the call reason is. So why are customers calling? And to do that, we integrate and leverage a lot of different data sources to build out this idea of a phone sojourn. So across the top is kind of what that would look like. So a customer picks up the phone and calls us up on an 800 number, and then that's going to be routed to an interactive voice response unit where the customer can hit the keypad or speak the phrase. And the IVR is trying to determine why the customer is calling so it can route the call. So the customer responds in the IVR, and then we get to label C here. That call routing software is going to look for the first available agent that can help with the activity identified by the IVR. So we find that it's related to technology. So agent one picks up. Agent has a conversation with the customer and finds out, well, hey, actually the customer would be interested in getting another product from the bank. So we're going to find a sales specialist to help out with that. So what's going to happen next is what's known as a warm transfer. The first agent is going to stay on the phone with the customer and introduce the second agent, the sales banker. And that happens in column F. And then at some point, the first agent drops off, and hopefully the sales banker was able to meet the customer need and the call ends. So the total duration of the phone sojourn was 441 seconds. And that's very different from each of the columns, each of the label columns. It's kind of how the data comes out of the box. So being able to string all this together and enhance it with IVR data and information about the agent's activity in the bank systems. Call recording helps us to understand much more about the phone sojourn. And was Wells Fargo able to address and solve the task that the customer brought to us when they picked up the phone? So we take all this data and we integrate it, and we seek to build a model that labels the tens of millions of calls that we get from customers every month and assign a call reason. In this case, it's what's known as mobile deposit, where a customer can take a picture using their mobile phone of a check and have that check deposited. It's pretty important in the United States. Still a lot of checks in the US. And this gives an illustration of an AUC diagram for that model. You can see it's quite steep. The model is quite good. And there are two lines. One is the event only, that just uses the channel behavioral data. And the second dashed line is if we include information from speech analytics. And you can see we do get a lift from including the speech analytics information in our ability to successfully label the call with the call reason, in this case, mobile deposit. So the lift that we get from other data unstructured data like transcripts of call recordings matters by what the call reason is. Some lift is bigger than others, kind of a lot. It varies across many dimensions in terms of what data is captured. So that's kind of an illustration of how we can use a superset of data in the Teradata platform to understand call. So what we talked about is a lot of different examples of using advanced analytics to kind of solve business problems. And here I'm really just trying to illustrate how Vantage can help address each of those case studies. So we looked at the customer sojourn path analysis visualization. Vantage has really excellent visualization tools beyond the sigma graph, or rather the Sankey diagram I showed you. There's a lot of different techniques to visualize data through time, which we can leverage. The machine learning engine is a key capability of Vantage that leveraging. Here was that hidden Markov model of customer segments. So we had all our different customer segments. We want to understand how customers transition across those segments, and we can develop this hidden Markov model to model those transition states. And most importantly, understand what impacts that transition. And what can the bank do to accelerate the transition to higher states that include more usage of digital banking? And there's definitely things that we have discovered and can now really realize in our strategy because of this analytical technique. And then payments. Payments is kind of an important thing in the bank. Payments networks are not a new idea. They're used a lot in understanding banking environments for sort of like central banks or cross-border payments, used pretty often in fraud. And here we have a graph analysis of a payments network graph of our customers paying each other and how they can understand and identify untapped opportunity. Text disambiguation is the combination of Python, sort of processing the text, and machine learning engines, and a whole library to analyze text, the parse text, match test, inverse term frequency, word embedding. If you're into text analysis, there's a whole library in machine learning that can be used in Vantage. And then kind of, I think, probably the best illustration of kind of putting all the pieces together of how we can leverage all this detailed channel interactions data in Vantage to address really important problems is labeling call reasons, use Python, obviously use SQL for the channel data, and then RStudio to develop the family of models that assigns a reason to the calls. There are about 36 call reasons today, and we go through and assign one or more of those call reasons to about 8 million calls a month. So we use it at a high scale, and it's quite useful for us. So those are the major things I wanted to cover. Obviously, I can't take any questions, but I'm sure if you would like to communicate with me, you could reach out via Teradata. I'd be happy to answer your questions. So there are a lot of things that go into this that make this successful, is having the data, having the channel data all in one place. Those dimensions I talked about, customer, session, sojourn, but it's only going to get you so far if you don't have some ability to find the method in the madness of using machine learning techniques or graph analysis techniques. All those things are critically important. So thanks for your attention. Hopefully this was useful to you, and I thank you for your time. Goodbye.